Slide 1. Good afternoon, everyone. My name is Marcelli, and my presentation today covers a critical recent cybersecurity incident, the exploitation of the React2Shell flaw, leading to the deployment of the highly sophisticated remote access Trojan, EtherRAT. This analysis provides a deep dive into the advanced command and control C2 mechanisms and persistence strategies employed by actors with ties to North Korea. Slide 2. The incident began with the exploitation of the critical React2Shell flaw, also known as CVE 2025-55182. The threat actor is strongly linked to groups with ties to North Korea, DPRK. The targets are primarily blockchain and Web3 developers, often lured through fake job campaigns. The payload is EtherRAT, a novel, sophisticated remote access Trojan, RAT. This campaign is part of the long-running social engineering effort known as Contagious Interview. Slide 3. Let's begin with the entry point, the React2Shell flaw. This is a maximum severity vulnerability, scoring a perfect CVSS 10.0, impacting React server components. Since RSC handles server-side rendering, this flaw grants the attacker remote code execution, RCE. The initial attack chain involves exploiting the flaw, executing a base64 encoded shell command, which then fetches and executes the next stage shell script. The choice of targeting RSC demonstrates the attacker's ability to adapt to modern JavaScript and Web3 frameworks. Slide 4. The shell script initiates a critical multi-stage deployment, starting with Stage 1, Environment Prep. The script is retrieved via curl, and crucially, it downloads and installs its own dedicated Node.js v20.10.0 runtime from nodejs.org. In Stage 2, Deployment, it writes an encrypted payload blob and an obfuscated JavaScript dropper to disk. To minimize forensic artifacts, the initial shell script is immediately deleted. In Stage 3, Execution, the dropper decrypts the EtherRAT payload with a hard-coded key and then executes it using the newly downloaded Node.js binary. Slide 5. This is the core technical innovation, the technique EtherHiding. EtherRAT uses Ethereum Smart Contracts for command and control C2, treating the contract as a secure, decentralized bulletin board. The malware queries the smart contract to fetch the C2 URL every 5 minutes. This approach allows operators to easily update the C2 URL if it's taken down and effectively resists traditional takedown methods based on static domains and IPs. Slide 6. The C2 is further secured using consensus voting across 9 public Ethereum RPC endpoints to ensure reliability and resistance to interference. The process queries all 9 endpoints in parallel, collects all responses, and only selects the C2 URL returned by the majority of these nodes. This design is crucial. A single compromised RPC endpoint cannot redirect the bots to a sinkhole. Furthermore, researchers cannot poison C2 resolution by operating a rogue RPC node, requiring a coordinated attack on multiple nodes. Slide 7. EtherRAT is designed for long-term operations with the goal of achieving persistent, stealthy access. It employs an aggressive strategy by establishing 5 independent Linux persistence mechanisms. These mechanisms include systemd user service, xdg auto start entry, cron jobs, bash rc injection, and profile injection. Finally, it possesses a self-update feature. When updating, the C2 returns a differently obfuscated version of the code. This polymorphism is deliberately designed to bypass static, signature-based detection systems. Slide 8. The social engineering vector of the Contagious Interview campaign has evolved, shifting from exploiting the NPM ecosystem to focusing on Microsoft Visual Studio Code, VS Code. Victims are lured to clone a malicious repo as a programming assignment. Opening the project in VS Code executes a malicious tasks.json file. The run-on folder open configuration causes the script to auto-run the moment the project is loaded, downloading the next stage payload without the victim's active execution. The DPRK actors are now using Vercel almost exclusively for hosting infrastructure. Text in square brackets represents sound effects, other non-speech elements, or emotion, style, or reading for the text after the text. Slide 9. In summary, EtherRAT is designed for persistent, stealthy, state-level espionage, moving beyond opportunistic attacks. The sophistication of EtherHiding and consensus voting makes C2 disruption significantly more difficult. The malware's adaptability resists traditional detection and takedown methods. My recommendations for mitigation are highly focused. First, immediate patching is essential. Prioritize fixing CVE 2025-55182 React2Shell and similar RCE flaws. Second, supply chain vetting must be strict. Implement rigorous policies for executing external code and train developers to manually review files like tasks.json. Third, enhance EDR and anomaly detection. Specifically monitor for the unique network signature, concurrent queries to multiple public Ethereum RPC nodes. This is key to finding the EtherRAT consensus mechanism. And fourth, monitor outbound network traffic for non-blockchain-related applications attempting to communicate with known public Ethereum RPC nodes. Slide 10. Thank you very much.